Hi, MRK here, and welcome to my new video. Well, long time no see, friends, but I didn't have too much interesting things to show past few months. But this changes today. This is the day where I show you something huge. I mean, relatively huge. It's kind of huge for me because this is one of those problems that I was trying to solve for a long time, and this is the day. This is the day where I solve it. And well, you saw the title of the video, so well, you know what is it about. But let me just clarify. We want to pass arrays to materials, and every resource I found online just said that it is not possible, and it cannot be done, but it feels possible, and I wanted to do this, and I think that you just had to find a way. And what arrays am I talking about? Because it's not every kind of array, right? We cannot really pass pointers to objects. We can't really pass strings. But if you think about it, C++ or any kind of language, every time you deal with some kind of values in programming, is just, it's just numbers, right? So it's kind of up to us and of course the language to interpret what kind of informations those values are, right? So even though we can only pass values, so numbers, we can kind of interpret them as something else if we wish. But in this video, I'm just gonna show you how to pass arrays of just standard float values, which, I mean, you can, round to an integer or modify as you wish, and maybe kind of take them out and convert to a string if you wish. Later maybe you figure this out, but this is not the topic of the video. We just want to pass array of floats and do something cool with those floats. And why am I doing this? Like, what was the initial strike in my brain? Like, why would I need arrays in my materials? And the first problem I had where I needed arrays was the time where I was making a fog of war, actually, because in that fog of war I kind of solved it by using distance fields. So every object was just, using distance fields, and the fog was checking out those fields and just adjusting accordingly. But this has a drawback of, well, not really being able to use distance fields in any other meaningful way other to be used with that system. So it kind of, deletes that that distance field from our array of things we can do, right? So to not use distance fields and to just try to come up with other solutions, I thought about passing array of locations. So what if we could instead of using distance fields, just check the location of each of those actors and pass that to a material. And then from that material, we could just take those values out, loop through them, see if that location is in our fog or wherever, and just adjust our fog accordingly. So this is what I kind of figured out recently. And well, it kind of works. My example works a little bit different to a fog because it works in other way. Here we have a ball that basically acts as a sensor. So if it gets close to one of those actors, it just indicates that it is close to that actor, and it is not using distance fields and any other stock Unreal features. Just it uses pure location and compares the distance between that actor, and if it is if it is close enough, then it will change the value. So let me show you how it works. Basically, we have a ball that has array of factors that it wants to check, and if we get close to any of that actor, it changes color to white. Of course, that white is purely visual, and like you can change it to whatever else you want. Just I made it white because it looks nice. And yeah, if we go to any direction, it just takes that value, calculates the distance, and figures out if it should be white or black. Same with any of those actors. And it's actually not that complicated to do, but like nobody did this before, so I think that this video will be very valuable to other game developers out there. And well, as all of my videos, it's basically a starting point, because I usually do things that people don't do. So this is a starting point for you guys to expand it further and maybe share your findings and your ideas on how to use this in your own videos. So okay, let's jump into the explanation and how this actually works. How did I do that? Let's probably start with that actor, this sensor actor. I called it actor manager because it has array of actors. So the name is not really indicative of what it actually does. It should be a sensor, probably BP sensor, but I called it actor manager because it has actors, and I think it's enough for this purpose. So let's jump into the blueprint and see what's up there. Okay, so we have an actor, and we have a few variables. First variable is, of course, array of actors, and then we have those things. But let's not get ahead of ourselves and just do this step by step. First thing I do is just check if the actor array is not empty. It's kind of not necessary if you know it's not gonna be empty, but it's good practice to just check if there are any errors. Then I do a simple sequence, and then I go to this. Basically, we kinda want to have some kind of visualizer. You don't have to do this, it's not mandatory, but you have to do something with those values. Not have to, but that's the whole purpose, isn't it? Like to actually do something. So we take a sphere. It can be any other mesh, whatever you want, that can hold materials. Then we assign special source material. I'm gonna show it later, and we make a dynamic material instance from that. So just because we want to update it once or many times in runtime. Second thing we do is making a render target. And this thing here will actually be our array. And you see where I'm going. What is this array that we want to pass? If you know what render target 2D is, then you basically already know what I'm gonna do. Because you cannot pass arrays to a material, not normal arrays. But materials do work very closely with textures. So the secret sauce is actually using a texture to pass variables, well, to pass values. And what we are basically doing here is making a new texture. We are, of course, saving it. And the size is basically height 1. And for width, we are using the length of our array plus 1. Because for some reason, it doesn't work with just the length. It needs that extra one space. Maybe I did some error in my code, and it just needs that plus 1, but I didn't see it, so I just add it so it works. Without it, it just loses the last index. So, I mean, if you want to follow me, just add that. And next thing we do here is, of course, a format. And we can choose a lot of different formats, as you can see. But this basically is the highest and the only we need, because if we choose something smaller like RGBA16F, then as you can see, our range is only up to 65,000. And excuse moi, locations in world space are pretty big, like it can definitely go beyond 65,000, right? So fortunately, we have RGBA32F, and that is pretty effing huge. And this is pretty much what we need. We can, of course, go smaller if you kind of want to use that array for small scale values. You can, of course, use RGBA. You can use any other format, but you know, just depends of what you need and how much space do you have, because you know, using small values with high value range is just waste of space. So just figure out what you need in your project. Another thing is that if you would like to export that texture, and you could, then you cannot really do an export PNG with anything higher than RGBA 8. Because if you try it with 16F or 32F, for that matter, it will just throw an error. So keep that in mind. If you want to export PNG, you have to use RGBA 8. If you don't care about exporting, then use whatever. Oh, maybe, well, you can export higher values, but you have to use EXR. I think that's the format that's called. And it kind of works, but it's hard to display it anywhere. So yeah, if you can open EXR formats, then, well, go ahead and try to export 32F. Okay, so that's the second step. And the third step is actually applying the array. So let's jump right to that third step and see what's up here. I made it as a new event. It could probably be a function, and if you want, you can even hook it up to event tick if you want it to update constantly. But if your objects are static, I mean, I am explaining as if we were making a sensor, then probably those objects could be static. If they are static, then you just want to call it on begin play and, you know, don't waste the resources. But if you need to have it updated, then you can use event tick or just make a new timer, set timer by event, and just, you know, adjust timer accordingly. Maybe you want it to update every 2 seconds. Just don't waste resources. Optimize your code, guys. And yeah, let's move on. I'm also checking if the array is not empty, because I mean, the array can be variable. You can just remove some things from here and it has to update. So check if it's not empty. This is a validator. I didn't really use that, so we can delete that. And then we are actually starting a transmission. So how do we write to that array? Because it's not just a regular array that we can just add to. We have to draw to a texture, and that's how we add values. So we take that array, block array, which is our texture render target we made here, and we start drawing. Draw canvas to render target. You can skip that step and just paint anything you want right away. But this is an optimization because it starts the drawing process, and before it renders it to the texture, it well, those words might not have been very accurate, but let's just say it optimizes steps needed to draw something to a render target. Because first, you need data to draw, and then you need to draw. So now we are beginning that process of drawing and not actually drawing. If that makes sense. I mean, I hope it does make sense. I probably did a very poor job of explaining it, but use this as an optimization, basically. Then what we need to do is actually loop through actors locations. We take every actor of that, we take the location. You can actually save any kind of data you want that is vector 4, because that's what you can save, vector 4, and we add actor to an array, and we do it by drawing a box. This is basically drawing a pixel, because the box is screen size 1, thickness 1, so it's basically 1 pixel. We draw it to the canvas we saved before. Screen position is basically index. I made it ×2 because I actually don't remember why I made it ×2. It could probably be just 1. I'll test it. I didn't check that before. Let's just see if that works with 1. It doesn't work with 1. Okay, so I did this with a reason, but I don't remember what was that reason, why that ×2 works. Maybe some of you guys are smart enough to answer that. And yeah, render color is basically data we want to save. This is debug stuff I use to just check if that works. So this is not really necessary. And yeah, we save vector of those 4 floats. We add it to an array, and last step is basically end drawing. So we actually save those values to our texture, and we load that texture to our DMI. So this thing we did at the very beginning. We upload that texture, and then we can use that texture as a parameter in our material. And the next step would be, actually scripting the material we want to use. But this is the general solution to actually using arrays, passing arrays to a material. This is how you do it. And the second part is actually taking that array and using it in a material. But before we go into that, I'm just gonna show you what nodes I use to export the render target. There are a few things you can do to export the actual texture, like full texture. You can use export to disk, and test PNG. Just do that. If you want to export with PNG or probably JPEG or BMP, then you have to use RGBA 8. And if you want to export anything higher, you have to use EXR, basically. And you can also check the raw pixel data of those pixels you just saved. But this also works up to 16F. So you cannot check any 32-bit values. You can only check up to 16F. So if you work with 32, then, well, this whole thing doesn't really work. But you can use it if you have some smaller values. I actually use that, and this is easier to just read whatever pixel you want, because this is basically a 1D array of vector 4s. So yeah, this is just an index and this will always be 1. All right, so this is the export part, and let's go to a material and let's see how that sensing actually works. This is the material and it looks very simple, but that's because most of the code is in the custom nodes. So one of the reasons is why you can't really pass arrays to a material is because in materials we don't have any kind of loops. And all that means that we cannot really loop through an array. So passing an array wouldn't really make any sense in that sense of stock array nodes. But fortunately, we can actually use loops, just not as a node. We have to use loops in a custom node that we have to write in HLSL. And this is what I did. Basically, this location, this is a text object parameter. You can do this by just doing texture object parameter. This right here. This will do this. It doesn't really matter what texture you assign here, because you change the texture for something else. But to make it work in that preview, you should probably choose a texture that has a sampler type of color. Because if you change it to UE logo, it will be linear grayscale and it might produce some different results. I'm not really sure, but I think if we use it with colors, then it doesn't work that well anymore. And yeah. Let's go back to the default texture. This is the default texture. And what do we have else? Well, basically text chords. So just type text chords because we need to pass it to the function. We have some kind of threshold. This can also be a parameter. We can convert it to constant, but I just use it as a parameter. We can then change it from the BP. This is this, so we can just set parameter, set scalar parameter value, just type threshold and just assign whatever you want, like 500 or something, and it will use that value. So it will be now pretty far away. Actually, did it work? Yeah, I think it did, because it was way like here, right? So yeah, it works, but I'm not gonna use it because, yeah, constants. And then we need to have an actual position of what we want to compare. If that's a sensor and we want it to be kind of fluid, then we use absolute world position. This takes the world position of the pixel we are checking right now. And this doesn't have to be like that. We can just check the object position. Not scale. Object position WS, so absolute. And if we pass it to here, it will just use the whole object as a comparison. So now when we get close, it just snaps to white instead of using that smooth scale. It doesn't use every pixel now, it just uses the whole object. So that's how you do it. And yeah, we use the custom function and we plug it to the base color. We can plug it to whatever we want, of course, but testing purposes, it's a base color. And what did I do in that custom node? Basically, to make that custom node, we need some inputs. So go to inputs below and choose just input name text, UV, position, and threshold. and this will make those 4 inputs and plug it to stuff you see here, right? And the actual code. What does the code do? In that version, we are basically checking the distance between this position and the location we are inputting. And in this version, I'm actually doing something different and using just colors. So if we check this one, we can see that it uses actual colors to represent the proximity. Actually not sure why is this working like that. It kind of worked differently, but I was also using a cube, so let's just focus on this one, the sensor node. But you know, just keep in mind that yeah, you can do a lot of things with that. Just go crazy, go creative, and experiment. But this is the code for this sensor thing. So what are we doing? We are making a dimension variable. This is uint2, so basically 2 unassigned integers. Then we take dimensions of that texture. We could just honestly take x, because we are basically using x, so kind of don't know why it didn't do that. So yeah, I mean, you could, but in case you want a 2D array, then you can just use full x and y dimensions. Then after I take those dimensions out of the texture object, then I loop through every pixel, basically. I take the pixel, I calculate the UV, taking, of course, the middle from the pixel and dividing by the dimensions. Then we sample the current pixel from those UV coordinates. So we save it to a sampled color, and then we calculate the distance between the sampled color of that pixel and the location, well, position we input here. And this is basically what this code is doing, right? Then we check the distance. If it is below the threshold, then we return 1, and if not, then basically we are not close to any of those objects, and we return 0. And of course, you can change this code to actually return something else than 0. You can return float 3, float 4, or any kind of combinations of those. So go crazy, and just remember that if you are actually changing the output value from 0 to, let's say, 1 and 0, so float 2, then you need to change the output type from float 1 to something else, right? 2, 3, 4, and material attributes. I am actually not sure what that will do, but you can probably then break material attributes and use those. If you can use HLSL good enough to actually make those attributes straight in that custom node. But I assume you probably don't, so just stick those to those values, float 1, 2, 4. And that's how you make an array, and that's how you use the array. This is basically our array, and this is our loop. And that's it. That's it. It wasn't really complicated, but it took me 2 whole days to figure out, which is actually not very much. I was thinking about this problem for much longer than that. But yeah, this is the gist of it, and take that knowledge, please take knowledge and expand it further. This is basically just the beginning of whole new level of possibilities you can do. And probably I'm gonna actually use it in our Fox system to swap it from distance fields to the locations array. could be a good topic for a next video. So yeah, that's it from me. I hope you enjoyed the little video. I hope you learned something. I hope you find it as interesting as I find it. And yeah, see you next time. Bye bye.